Hey peeps, it's Sophie here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with the 2018 grade 12 physical science paper, and this is question 2 on motion. Okay, so it says a block of mass 8 kilograms is placed on a rough horizontal surface, that means there's friction. The 8 kilogram block, which is connected to a 2 kilogram block by means of a light inextensible string passing over a light frictionless pulley, starts sliding from point A as shown below. Okay, so question 2.1 is a theory question, and it's asking to state Newton's second law of motion in words. And I've written that in the pink sticky notes, and it says, when a non-zero net force acts on an object, the object will accelerate in the direction of the force, and the object's acceleration is directly proportional to the force and inversely proportional to the object's mass. Cool. 2.2 asks if we could draw a labeled free body diagram for the 8 kilogram block. So we're going to keep in mind that they've said that it's on a rough surface, so we know that there's friction, and we know that there's some tensile force in this string here, and we know that it has a weight. The block has a weight and a normal force because it's on some surface. So let's start. So that means that there's a normal force, as we said, there's a weight of the block, there's some tensile force, and we're going to assume that it's always pulling outwards from our little free body diagram dot, and we know that there's a friction force that's opposing the direction of motion. Always opposes. And this angle here is 15 degrees, as they've given us. Okay, so that's our free body diagram. So, in 2.3.1, okay, first of all, 2.3 says, when the 8 kilogram block reaches point B, the angle between the string and the horizontal is 15 degrees, and the acceleration of the system is 1.32 meters per second squared. Okay, so it says, give a reason why the system is not in equilibrium. So the most obvious reason is that acceleration of the system is not equal to 0. They've given us that acceleration is 1.32 meters per second squared. So that's why it's not in equilibrium. It's accelerating. It's got some sort of resultant force. Okay, 2.3.2 says use the 2 kilogram mass to calculate the tension in the string. Okay, so let's do a little free body diagram for the 2 kilogram mass here. So we know that it has some sort of Fg, and well, that's its weight, and then it's got some sort of tension force up there. It's pulling it upwards. It's kind of a reaction force to the gravity. So we know that it's accelerating. So we're going to start with the Newton's formula. F raised is equal to mass times acceleration, and we're going to assume that all of our downwards directions are positive. So that means that all of our down forces are going to have a positive sign, and all of our upwards forces are going to have a minus sign. Okay. So then we can go on and say that, okay, so Fg, so that's our force of gravity or weight, that's going downwards, so that has a positive sign, minus the tension force going upwards, and that is equal to the mass of the block, which is 2 kilograms, times the acceleration, which is 1.32, and we know that that's going downwards as well, because it's told us that the block is accelerating to, the right. Okay, cool. Which translates to down for the 2 kilogram block. Sorry. Okay, cool. So then we know that the weight force is just 2 times 9.81. Minus tension is equal to 2 times 1.32. And if we put that in our calculator, we get T is equal to positive 16.96 newtons. Now, just because it's positive doesn't mean that it's pointing down. It means that our assumed direction was the correct direction. So tension going upwards was correct. So that means that this is going upwards. That's what direction the tension's going. Okay, so let's move on to question 2.3.3. It says calculate the kinetic frictional force between the 8 kilogram block and the horizontal surface. So let's just go to this new slide. Okay, so we're going to quickly draw a little free body diagram for the 8 kilogram block. So we know that this has some sort of tensile force here at an angle of 15 degrees. And we know that it has a frictional force. We're only going to consider the horizontal forces now, because we know that because it's on a surface, the normal force will balance the weight force out because it's not moving in the vertical direction and the vertical component of tension. Those three will balance each other out. But there'll be a resultant force in the horizontal direction because it's accelerating in that direction. Okay, so they want us to calculate the kinetic frictional force. So let's start with Newton's formula. So you know that Newton's formula is F raised is equal to mass times acceleration. Now, we're going to only work with the horizontal components. That's important. So we know that the horizontal component of tension, so we know that tension is acting in this direction. So it's going to have a horizontal component and a vertical component, and this is 15 degrees. So if we assume to the right to be positive, we know that all of our forces to the right are going to be positive in our formula. So we're going to go the horizontal component of the tension, which is T cos 15, minus, because of the frictional force acting in the opposing direction to motion, F friction is equal to mass times acceleration. Okay, so we know T cos of 15 minus the frictional force is equal to 8 times 1.32, because we know that that's positive going to the right, and it's the acceleration that was given to us. Okay, we know our tension is 16.96. We've just worked that out. And remember that tension across the whole cord is going to stay the same because there are no losses, because there's no friction in the pulley, etc. So that's 16.96. And that is going to the right, so that can still be positive. Cos 15 degrees minus F fric is equal to 8 times 1.32. And if we put that into our calculator, then we get the force of friction is positive 5.82 newtons. So because it's positive, we know that the assumed direction was correct, so we know that that is to the left. Okay, great. So then 2.4 says, as the 8 kilogram block moves from B to C, the kinetic frictional force between the 8 kilogram block and the horizontal force surface is not constant. Give a reason for this statement. Okay, so the vertical component of tension is going to slowly change as it gets closer to the pulley, because the angle is going to increase as it gets closer. So it's just going to keep increasing. So because the vertical component gets larger, so we're going to write here, we're just going to write with arrows. So we know that the tensional force, the vertical tension force, is going to get bigger, which means that your normal force is going to get smaller. And because your force of friction is equal to the normal times this constant surface friction, then we know if a smaller normal force results, then we're going to have a smaller frictional force. Okay, then for 2.5, will the kinetic frictional force calculated in 2.3.3 above change? Choose yes or no and give a reason. So the answer is yes, because it depends on the surface. So oh, sorry, I didn't actually read the part above it. So this part here basically says that it's replaced by another horizontal surface made of a different material. So that's why the answer is yes. Because your frictional force depends solely on the surface. So yes. Because if you change the material, it's going to change that coefficient of kinetic friction, which means that your frictional force will change if the material is changed. Okay, so that's it for this question. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. Also be sure to visit our website for more of these epic tutorial videos. And if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until next time, stay epic.